this is probably just it's good that this is here so I can give you some sense that there's strange things can happen. So this is a completely made up network where we have 10,000 nodes in one of the one side and 100,000 of the second type of node. They're going to have these nodes belong to, on average, 1.5. Sorry, these nodes belong to an average of 15 of these, and the other way around, right? So 10,000 times 15 and 1.5 times 100,000 are the same, right? That's the number of edges between these two classes of nodes. So these, if these are, let's say there are lots of, these are boards, this is a big thing, and these are directors, right? So each board has about 15 people on average. Each director sits on 1.5 boards, right? Many more directors than boards. So this is and then randomly wire them up. Yep. And in this one, I think the underlying distributions were they Poisson? I think they might have been, yeah, yes. So this is a weird looking thing, right? This is the number of, and this is written in an actor movie version, right? So this is the number of co-stars for actors. If they're randomly, so you have actors that are randomly allocated to movies. And so you see, what you actually see is peaks around, really that's a peak around 15, and that's a peak around 30, and that's a peak around 45. So it's, while it's this is a weird network, right? This is, a weird distribution. This is doesn't fit an obvious thing, but it actually has a good story underneath it in that when we're talking about, I guess it would be 14, right? So you have, would be the average there. So you have an actor, if they're in one movie, then they have just 14. On average, they'll have 14 co-stars. If they're in 2 movies, then on average, they'll have 28. Right? And they won't share, right, because it's random. None of those 2 sets of 14 will overlap with each other. And then up here to 42. Because you're in the movie, on average, there are 15, so 14 other people. So this is from a simulation, right? So, and in fact, I'll show you later on that, or in the next, when we come back, that there are real systems where this is actually, you see these kinds of distributions, and in fact, a random bipartite model works, right? So you've got these degree distributions for the individual things like movies. They have some distribution for the number of co-stars, for the number of actors in them. Actors have some distribution for the number of movies they're in, which you can imagine is sort of something that falls away, right? Lots of people who are in one movie, some are in 2, some are in many, but they're going to be rarer. But movies in general will have some sort of there isn't sort of, that's not going to be a skewed distribution. Poisson distributions for affiliation numbers. All right, so we'll build this story up next time, which is a while away, and that will be we'll really put a box on it, and we'll move into other things. I'm going to talk about networks still after the break to some extent. I know we need to, but I want to get into stories and language and so on as well. I know we need to get to projects, so I will, and I've talked with some of you about that already, but I will put some stuff up on the site and email and send out a plan. Okay? All right, so that might not have been super fun, but I just want to, it's a dosage of medicine for you guys. All right.